Happy Tuesday. Figured that today we would go over what it is to have transparency with data in a way that is accessible. Because there's been more of a growing conversation around data transparency, not having so called black boxes with generative AI, as well as really giving access to that question of, or to answering that question of what is quality data. So, right, and really, out of one, but I would submit for consideration that you can't really define it for somebody else. Quality is defined by, well, each individual person, as well as, right, the standards that we ascribe to. So, what we're going to do with this is, I come here, actually, because I'm going to be programming here, so we'll do a little switcheroo. Boop, boop, boop. Okay. Come here. Much better. All right. So, uh, we are on Hugging Face, which is open source and available for everybody to use. And, right, so high level, we're going to just look through one of the data sets that are on here. And this is from this Yale BIDS Zulab that recently published this great paper about MeLLama, Foundation Large Language Models for Medical Applications. This being on GitHub and is accessible for anybody to see. It's a fine tune for Llama 2. And right, it really, it's about shared learning for everybody and about the fact of anything to learn from academia, industry, and really a rising tide raises all ships. And so this is all done with the express intent of acknowledging the great work that was been done by the folks here and stating that as if anything that I'm doing feels like I'm standing on the shoulders of giants, because I undoubtedly am. And so with this, I'm just trying to do my part of being able to fill in gaps for understanding and access for those places that aren't the big academic labs, right? But I want to make very clear this is not like industry versus academia. This is everybody learns together. We're all learning, and it's important that we all come at this in a unified fashion. So what we're going to do with this is going through and understanding at a high level as well as a practical level what quality data really is. So this is a newer data set that was made by these folks here. So you can see on Hugging Face, I'll tell you, 11 days ago. And this has 12,700 rows of data. Now, what does that actually mean? So one of the rows here, he has this ID here, and then has what this conversation is. And then it has some text here, right? And then this is the size of the file, and it's downloaded into this Parquet file, and this is how many rows it has. And so we can actually view this here, but let's say that we want to be able to actually go through. We don't have an internet connection, or we're going to go away for the weekend for a while. We want to be able to see and manipulate this data ourselves, right? And we see here that there's 3 different splits of the data. So train, validation, and test, which is fairly standard throughout. Some folks, you'll just see a test set or a train data set, and then they'll take a small component of that, so maybe like 10%, 20%, and make that their 10% of it being the test, 10% being validation. I'm not speaking to what is, isn't, or should be. This is just what is in this particular situation. So what we'll do here is we're gonna have that over there, and what was it? It was okay. So we're just going to. Sorry, I was just deleting some of the downloads here. So we're starting from scratch. That's the kind of whole purpose of this, right? Starting from scratch. So we're just going to go ahead and download. Let's download this one. the train. So we says Parquet file here now. And that file, train, is this right here. And so, right, but we can't actually manipulate that because it's Parquet file. And right, you can't use Parquet, just put it into Excel or Google Sheets. So what do? Well, we're going to code a little bit of Python to be able to visualize that, to be able to have that. And right, the goal of that is the fact of being able to save a little bit of money and save a little bit of time, because we don't have to necessarily farm out this conversion. Just write it and don't need to have anything super fancy just to run it. So I'm doing this for the terminal, not because for any other purpose, in the fact of pretty much every computer in the world has a terminal. So that's what this interface right here is regarded as. I'm running on Linux, which is an operating system, but so there are going to be some deviations depending on if you're on Mac or on PowerShell for Windows, but every computer has a terminal. So that's why I'm using this terminal here. And so let's see with this. So we're going to do, oh heck. And I have this nice little, one of the add-ons I've installed is a Rust-based one called Zoxide that just lets me use Z instead of the typical CD to move around. But that's more nerdistry than most folks need. At a high level, really it's just, right, you do CD, and then that goes into the directory you want to. So we'll just keep it nice and simple. And so we're going to we have to name our file first. So we have to make it. So we're going to do touch, which that is good, bad, or different. That is the format to make a file. So let's just call this something simple, P2V from, yeah, to CSV.py. All right. And then, you know what, I'm just going to use my text editor. That just helps me with the spacing. So we're going to see. So now, yep, we're in this. So we're going to do, so first things first, we're going to import. So when we make a Python file, which is what this is, and you can even see, there's something on here. This is that you can even see this little like Python symbol here. Is we're going to first import some libraries, and that all that really means, think of programming like building a car, or putting together an instrument, or I'm not going to say doing surgery because, right, but you're putting something together. And so think of the libraries as the parts of the car. And this one, right, you can have numerous libraries, and that can, because you're making a very complex car, more like a rocket ship, we're going to keep it relatively simple. It's, at least for this, there's parts it will be a little less so, but that's why we're doing this. So nope. Let me just make it so it's a little bit easier to manipulate. All right, so then we're going to define this function here. String. See how nice, because it just sort of and I think VS Code does this too. And if it doesn't, I'm sure someone will let me know. But yeah, it's a nice thing about the code editor that I use, which I guess technically is a text editor and not a code. You know what? I don't know. Is the fact that it is very lightweight. I guess all of them are lightweight. That seems a little silly, but it's really about being able to, how to put it? I guess the biggest thing is it has the ability to plug things in and get these little, some of the things to help, but it isn't unwieldy like I personally found VS Code to be. Right, and I'm probably just doing something wrong with that, so that's all fine and dandy. It's not about like, oh, I have to use this code editor. It's not. I don't want to add to or really I got nothing for that conversation because people are going to pick what they're going to pick, and it's the purpose of a code editor is to edit code. I mean, I know it kind of sounds like the joy, but it's about whatever you need to get the job done. Period. Full stop. And if it's not helping you do that, and you're spending more time just chasing around for stuff, which I have been guilty of, so I speak from experience on that. Well, then, kind of defeating the purpose here. So, it's taken me a long while, and my own person. This is probably a little bit of ego. Well, I mean, yeah, is that it is nice to be able to have something that you just feel like it just has what you need in that period. Like that's really nothing else. Because it just I don't know, it can feel very bloated with something like VS Code, but I'm also trying to do a few more things than the average bear. So yeah, PL scan parquet put boop. And at a very high level, because we don't need to turn this into some super duper science project thing, is what we're doing. We're taking the CSV file, or no, sorry, the parquet file, and we're just giving the instructions on how to be able to chunk that and into a more manageable size. And then with that, turning it into these first lazy frame and then data frame. So that way we can go ahead, chunk some, and be able to make that conversion more seamless. Because think of data as food, whether it's for a generative AI model or just any program in general. And typically, you don't want to, unless you've got some like one of those mega clusters, right? But you typically want to go ahead and, what's the term? No, chunk it, right? You got to chew it. You can't just like swallow all that data all at once. Otherwise, you might, well, yeah. So what you do is you go ahead and you chunk it, and then that makes it more manageable. And when it's more manageable, well, then the job actually gets done. Columns, D type is nested, boop, 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 df chunk equals df chunk with score columns and p expert string type equals pl dot utf8 right chunk to CSV file. Come if not, header written df chunk, right, CSV, output file, include header written equal true, else with open output file a as f df chunk dot right underscore csv dot f include header equals false. Place with now at the desired output CSV file path. And that just means where's it coming in? Where is it going out? Okay, file equals d downloads. Oh wait, oh shoot, what did I label that again? Oh, that's right. So you don't have to. This is a long, stupid. This is only format. It's what's typically you'll see happens there. So we're gonna name it something a little bit. What was this called again? MedQA R. I'll just call it. That's bad. Just MedCar. So. CSV file equal d dir name put CSV file this okay equals true. Almost done, promise. And again, this is the purpose of this. It's not about like, oh, hey, look at this. And this is to understand that when folks say that, oh, will AI be able to take something and like, are we going to need programming anymore? It's like, well, I would submit for consideration the answer to that is, well, how much control do you want over whatever you're going to make? And for most folks, if you don't really need to go into the weeds, well then great, don't. But I feel like medicine's a little different than that. And so it's not about you have to do everything yourself. It's just about being able to get to that level of, okay, this is how a thing that falls within the scope of what's important should be done. You automate the mundane and the routine, so that way you can spend the time being very deliberate on the things that matter. Okay, and so now we're going to create a virtual environment. Think of it like how in the Matrix, Neo and Morpheus, right, have those little virtual dojos to train in. Think of it like that. I'm using Conda, or Anaconda to do that. As a Conda certified educator, I am a big fan of using it and think it's a great service. And it's also open source and free. So yay, free. So we're going to call this, oh, I don't know, Park to and then we have to do Python equals 3.10. Okay. And it's thinking about it. It's putting in. You're not going to have all these channels here. Or should you? Oh, and let's see, Conda activates Park to CSV. Python. Oh, and then we're going to use Python's package manager, which is called pip. there's other things you can use, but we're just going to keep things simple here. Again, that's the focus. Simple, 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 simple. And simple in the fact of you don't need to run a bunch of programs or do all this other, like the code and the programs, there is complexity there, but this is about being able to remove that mysticism and just go, yeah, what is coding? I mean, just writing, just boop, 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 boop. And then you write it, and then the computer does the program because you wrote it instructions. So polars, because that's what that's the library that we imported earlier. So now if we're going to run that, oh shoot, what would we call it again? So we do Python par, and we know that the virtual environment is active because it says the name's right there, park2 CSV. So now we do Python. Oh wait, did we rename that? Yeah, okay. Par. Oh yeah, CSV.py. Okie dokie. So what did it just do? Oh my goodness! Would you look at that? Where there was no file, there now is one. Here, actually, maybe for dramatic effect, let's sorry, still get excited sometimes when I see when something like that works out. So here we have our download file. So Python par2 csv.py. Oh my goodness, it happened again. Okay. Oh, I forgot to mention nano. No, let's do nano par2 csv.py. So the reason this says D/downloads, that's because I have a D drive on my computer that I put in. If you don't have a D drive, then don't put D drive there. If you are on a Mac, I think, what is it? If you go to the directory that you're in, actually if you're in a computer, you put pwd, you should be able to see what path you can put in, and then at the end of it, just put whatever the file is. So here, let's see. pwd. So yeah, so like I put pwd there, and so I know that the path is d/forge, and so that's why. Now, but the downloads file that is in. Nope, don't do that. That is there. We go. Yeah, so this downloads file directory, there's that medcar.parquet and medcar.csv. So because they're in that downloads file, see it's /d//downloads, right? So with that, par2 csv.py. So that's why it's /d/download/medcar, and that's the dot is just the file format. So .parquet, .csv, .parquet, and then come here, Microsoft Excel, comma separated value file or CSV. So there you go. All right. Burp, burp, burp. So now we're going to open up this file here. Oh, and I want to make sure I highlight. So parquet file, 13,526 kilobytes. CSV file, 29,157 kilobytes. So, right, if you think about memory storage and what the OpEx is for that, operational expenditure, we're looking at more than twice the size of the data. So that is definitely something to be mindful of, because the more data, the bigger the data file, the more you have to store it, and the more that can end up costing. All right, so what are we looking at here? Well, it is breaking it down. Again, this is the point of this isn't about perfect formatting. It's about just being able to get visibility. So we're going to do a side-by-side comparison here. So we have this row here, med QA reasoning 6482, and that's this first column here, 6482. And then we have to go, we're going to go all the way down because it broke it down up into all of these different columns here, because parquet files, so I remember that columnar format, so column as in, right, just and so then we have here the input, and we see right here right? Input, 35-year-old man, comes a physician, comes a generalized weakness. So same there. Actually, here, let's do, yep. And so this was the first row, or the first conversation point for this. And it has, right, so we got the answer here. Oh, no, come here. The content elevated serum, low density lipoprotein. And I know this is probably a little bit different than what, when people think of quality data, really, and it's an important question, and one that's at the forefront of my mind pretty much always. The consideration is that we think of quality not necessarily in, well, did this come from Hoppenfeld's or what's the word I'm looking for? Wolters Kluwer, or yada yada yada. This is about, is it correct, and is it put into a format that aligns with the training for the model? And we're still really figuring that out. But then, right? I mean, we see, because if we, as we're, so the train, really the way to think about it, how at least I'm thinking about it, and right, learning from the industry and doing our best to all like get better together, is you identify a task. So let's say, advising students. Well, what does that really entail? Well, a lot of things, because students want to know about everything. Everything from how do I do suturing to what's the best suit to wear. I mean, right, there's a lot of different questions. And so it's about being as specific as possible. Okay, what are we going to define the tasks to be? Like, what are the most likely things? And then building a data set around that even can be extrapolated from. So, right, because you're not going to anticipate every single question that's going to be asked, nor should you. But it's about, okay, well, what are the major things, the things we want to make sure that we get right? And then using retrieval augmented generation / some coaching of, hey, maybe don't ask the model about what love is, because, as much as we'd like to think that we can, right, of, well, like, help me to understand this personal relationship. It's like, well, that not every question in life is going to have an easy, direct, producible answer, but that's why it's life. That's what makes it great. Challenging, frustrating times, sure, but the best things in life are difficult. That is, I mean, right? Anything worth having is going to be difficult. So too, we do our best to create training in the data so that the models can reflect the right, or the domains of interest and the training protocol. So whether it's excuse me, supervised fine tuning, reinforced learning with human feedback, direct preference optimization, odds, ORPO, can't remember what it stands for, odds ratio preference optimization. That's what I want to say. Right, and there's Qdora. There's like a new training process like every day, it seems like, if not every other day. And so it's more about, to me, my guiding principle is, okay, what is the way I can get the most efficient training on the smallest models that are quality, that then can be deployed, serve without driving a huge expenditure, whether that's both the environmental cost as well as financial cost. Right, that's why we're using our own hardware, we're not outsourcing it to the cloud, right? And that's a decision that comes with a lot of challenges by itself, but it's just one that we're making because of the fact that it then gives us that autonomy to place our investment to other areas. So we're able to create cloud native applications, cloud native models, and deploy those in such a way where we aren't eating that training and inference cost, that storage cost immediately off the bat. That it's up to what the clients want to say of, okay, we want to use this particular infrastructure that we use Microsoft Azure, or we use Google Public Cloud, or we use GitHub. So that way we're only having to incur cost when working with a client based off of what their needs are. If they're like, hey, we already have a cloud infrastructure set up with Azure and we just want to be able to have things deployed to that, well, then that saves everybody a lot of time, money, and energy, because we can then package things up and make it amenable to that. We don't have to, there's no buying of a bunch of new infrastructure for anybody. It's just, all right, here's the service you want, package it up, bingo bongo, away it goes. All right, so, oh, almost forgot. So I'm going down. There we go. Nope, don't want to replace it. All right, so this is that third column, this text string column. So, all right, and then we can see this down here, decrease, okay. So yeah, so and I'll go ahead and sling this code up into, what's it called? Up onto the YouTube, or I should be able to get it up like onto GitHub or somewhere. I don't know. Put it somewhere. But what the takeaway I want from this isn't about who can code, who can't code, and putting up another barrier or another only people who are knowledgeable in this. That's not the point. The point is about taking something that is complex, and that really is a source of consternation for folks of, okay, how do I, what is a good data set? How do I find a good data set? What are people doing? I don't even know where to start. I'm humbly, with open arms and a full heart, will tell you Hugging Face is a good place to start. And, well, we can start with the different institutions, whether they be academic or in industry, right? And Hugging Face by itself is industry, so we're kind of getting both shakes here. But then look at that and see for ourselves, right? The process of peer review is about, we as people, everybody in the community looks through and identifies, okay, what works, what doesn't work. And really with AI, it's, if you're wrong, it becomes very clear very quickly. Just think like the Google Gemini model when it first ended up coming out, and just sort of the very acute learning that occurred around the viewpoint on certain historical events. The feedback loop is very, very quick and very, very loud. So this is about helping folks be able to avoid some of the learning pains, while at the same time still getting the information out there. So to summarize, in looking through, and one place to look, again, we still have it all up in the public. If you go to huggingface.co/compass, that's compass with a Q, and you click quality datasets. Again, these are all datasets that we've been just collecting from the open source community. I have not used most of them myself, but collected them from the standpoint of learning from and wanting to just have somewhere where people can at least start and really start getting a sense of, okay, what's being used, without having to just sift through everything themselves. Because some of these, without having gone super duper deep, but I am not likely going to be using MedRag because I just don't want to deal. There's Grey's Anatomy that's right there, and that's just not where I'm planning to use. So I will look for something else that may end up having that. And they probably have a agreement with an organization to work that. Not speaking to that. That's just I don't have that agreement, so I'm going to avoid that. Right, and then just seeing about the different data sets of what really is being done and across this whole thing, because it's just fascinating how different people are doing different things, and really how they're getting good result based off of the different data sets they're using. So let's see. Yeah, I think that is pretty much it for this one. That was a little bit longer, but I do really hope that was helpful to be able to see that code and see it, to remove some of that mysticism of only somebody who's look at me. Come on. If a country bumpkin like myself can sort of unga bunga eventually just do a little bit of elbow grease, a little bit of self-study, a lot of YouTube, and pick this stuff up, well, that anybody can. And I think that's really the point I want to leave with, is that this is about anybody can do this. Anybody can learn. Anybody can build this up. And right, we want to have amplifying human intelligence that lifts and unites and really accelerates people to a better place. And really excited for where that's going to go. So with that, I will, until next time, and oh yeah, like, subscribe, all those things, please and thank you. And I will see you in the next one. You take care.